finding the nth root, so the roots can change when, I don't know, like for lack of a better word, invisible math. You know how if I had $5, if I just saw the number 5, that'd be $5, but then there's 5 decimal point, and you don't always see the decimal point, or 5.00. A number like 7 is to the first power, but you don't see to the first power. So when things are super common in math, sometimes we don't write them. And in one of those instances, that is a square root. So a square root is the most common root. So if you don't see a number, the little index number there, then you know that it's a 2. And if it's something other than a 2, which is less common, then they'll write what the root number is. Okay, so then from there, finding these roots, this one here says, well, 4, what number times itself is 4? 2 times 2 is 4, so the square root is 2. Now, if you tried to think of 2 identical numbers that multiply together to get -4, we can't do it. Positive 2 times positive 2 is -4, or excuse me, positive 2 times positive 2 is 4, -2 times -2 is 4, positive 2 times -2 is -4, but those two numbers are not identical. And that's why we don't have a real solution when I have an even root of a negative number. Now, when I go with the odd root, cube root of 8, we're saying what number times itself is going to be 8. Well, positive 2 times positive 2 times positive 2 is 8. So the cube root of 8 is 2. We have an odd root, and we are going to be able to find the answer because for -8, -2 times -2 times -2 gets me back to -8. I have 3 identical numbers multiplied together, so the answer is -2. So the first thing that you want to remember is that if you have an even root of a negative number, you are not going to get a real solution. But if you have an odd root of a negative number, then there is going to be a real solution. Okay, so let's take a look at a few examples. I have the cube root of -27. So because the root is odd, I am going to have a real solution. And thinking of three of a kind that get me back to -27. -3 times -3 times -3 is -27. So the cube root of -27 is -3. Okay, we have an even root, but it's of a positive number. And since it's 6, the 6th root, we want a number times itself, times itself, times itself, times itself, times one more to get me back to 64. And it happens that 2 times 2 times 2 times 2 times 2 times 2 is 64. So we have 6 of a kind. So the 6th root of 64 is equal to 2. All right, now this one here, the 5th root of -32, I am going to have an answer because the root is odd, and I'm just thinking what number times itself 5 separate times is going to get me back to -32, and it turns out that -2 times -2 times -2 times -2 times -2 is -32, so it's 5 of a kind there, so the answer is -2. This one, I have an even root and I see a negative, but the negative is on the outside. That has nothing to do with this root. It's -1 multiplied by, so we have -1 multiplied by the 4th root of 81. So this -1 is just hanging out there by itself. And now we need a number times itself, times itself, times itself that is 81. So that ends up being 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is going to be 3. So we end up with now -1 multiplied by 3, and then -1 multiplied by 3 is -3. Okay, so here's just 2 last examples. This one, negative cube root of -8. Remember, the negative in the front just means -1 multiplied by. So I have -1 multiplied by the cube root of -8. Then I want to think of a number times itself that gets me back to -8. And that is -2 times -2 times -2. So the answer to the cube root of -8 is going to be -2. So now I have -1 times -2, which is +2. Okay, and then this last example, there is a negative underneath here, and that's an even root. You cannot take an even root of a negative number and get a real solution. So immediately, I know that this is no real solution.